that. That's computation. So k plus 1, k plus 2, 2k plus 3 divided by 6. What about that left-hand side, guys? What's the trick that we need to utilize at this point to maybe have a punching chance at this?
Induction.
Right, we need the induction step. What are we substituting by induction, guys?
The whole sequence.
Except for?
Except for that last term that you had,
Correct.
k plus 1 squared.
Yes, sir. So, Greg, we're going to substitute 1 for 1 square plus 2 square plus 3 square up to k square. And what are we going to substitute for that, sir? Yep, this ugly-ass formula right here, right, guys? So we're just going to plug all of that in. So that's going to be k plus 1, 2k plus 1, all divided by 6, okay? And that's not substitution, that's induction, okay? If you do write induction on the examination, or if you write substitution, it'll cost you a point, because technically it's one of the most important steps. And I want to make sure you guys understand the difference between induction, which is an assumption, and substitution, which is a given, okay? So, this is just by induction. I'm going to copy down this k plus 1 square term as well. Okay, and that just comes down. Okay. So this is just by induction / computation. All right. So that's fun. All right. The rest of the problem is very similar to the previous. Okay. So somebody remind me, because I forget everything already. Okay. What do we have to try to do to make left-hand side look like right-hand side? Or what did we do in the previous problem? Common denominator. Nice, John. Guys, isn't the common denominator 6 for this problem? Okay, we can obviously see there's a denominator of 6, so let's get that. And what I'm going to do is I'm just going to immediately write this as one mega fraction, if you would. Okay, so if somebody will check me just to make sure that this is good, k plus 1, 2k plus 1, plus 6 quantity, k plus 1 square, divided by 6. Okay? Does that look like a good mega fraction? At least for this problem. Maybe it doesn't look good. Okay? I mean, I think it's sexy, but, you know, what do I know? All right. The right-hand side looks exactly like what we already had from before. Okay? So right-hand side, k plus 1, k plus 2, 2k plus 3 over 6. So we're not going to mess with that. All right. Now, just like the previous problem, okay, there's going to be 2 ways that we can approach this. We can look for a GCF, or we could FOIL it out. What's the detriment to FOILing that out and then trying to factor it after that?
It's too big.
It's going to be a cubic, right? And how many of us want to use the rational zeros theorem to try to factor it out? I don't even remember the rational zeros theorem. Don't answer that. I'll pretend you guys did. All right. So, unfortunately, guys, if you do FOIL this out, you're going to get a 2k cubed. And you don't want to work with a cubic and try to factor it. Okay, it's probably not going to factor like by grouping. So, if I was to ask you guys for a common factor, what's the GCF in these 2 terms, guys?
K plus 1.
K plus 1, right? There's a singular k plus 1 that we can factor out. Let's factor it out. Okay, so we're going to go over here. Get a little bit more room to work with. So we're just going to pull a GCF out of k plus 1. Okay. So I'm going to pull out this k plus 1. We're still going to be dividing by 6. It's still going to be equal to that right-hand side. So there's nothing really that we're doing to the right-hand side until the very end of the problem. Can somebody tell me, if I was to factor out the k plus 1 from both of the terms that we have, does somebody think they might know what would be the remaining polynomial without FOILing it out as when we factor that
K,
GCF out?
2k plus 1.
Okay, so k, 2k plus 1, that's the first term. So we just lose the k plus 1 that's there. Okay.
Plus 6, k plus 1.
So we only lost one of those 2 k plus 1s, right guys? Right. Okay. What if you don't trust that? Don't you just go ahead and FOIL the k plus 1 back through? Okay. And if you don't trust that, then, well, I don't know what you learned in factoring. Okay. Look good, guys? Any questions? Okay. Yeah, it might not look good, but does it look correct? Let's just say that. Okay, it might not look good, but it's correct. All right. Still doesn't look like the right-hand side. There's no common factors here. So does anybody have a suggestion at this point, guys?
Give up.
Give up. That's a good suggestion, okay? I like that. Unfortunately, there's 25 young minds I have to make sure that get onto the next class from this stuff. So let's just assume that giving up is not an option.
Giving up and never enough.
Giving up and drinking? Oh, that's an even better option.
Oh, no.
All right. Let's say any sort of thing that'll help us lead to the correct solution of
We
this.
can use k plus 6 as one more fraction too, right? K, that's not going to solve anything, but it can. With a k-
Maybe something better than that. Well, not if it's not algebraically incorrect. It's not going to get us to the answer.
So inside the brackets.
Yeah, let's just FOIL out that stuff, okay? So let's just FOIL out, collect like terms in there. Usually we don't like to FOIL, but in this case we don't have an option. There's no other common factors, okay? So, just by multiplying and addition, so just some basic polynomial operations, k plus 1. If I was to FOIL this animal out, wouldn't I give it 2k squared for the first term? I have a 1k and a 6k. So it just becomes 7k's. And then I just have a 6 plus 1, or 6 times 1, which is a 6. All divided by 6. All right, so like I say, guys, we usually don't like to do that, but in this case, it's unfortunately the only way that we can go with this. Okay, is everyone okay, by the way, how I FOILed that out and collected like terms? Okay, just did just started distribution and collection. All right, is it possible that this trinomial might factor into something nice? And if it does factor into something nice, yeah, it just might factor into what? Maybe k plus 2, quantity 2k plus 3?
That's what I'm saying.
That's what I'm saying. Now, what if we don't know that? Well, we just guess, right? I mean, I wouldn't give you guys the proof. And then once we guess it, couldn't we just FOIL it back out to see if it works? So even if you're not a master at factoring your trinomials, you can just assume it's going to factor into this and just FOIL it out and see if it works, okay? Now that doesn't work in any other math class because most of the time your teacher says just factor it and do it, and they don't give you the answer beforehand, okay? But that's going to be equal to what we need. Now we can give up because we're done. Yeah, at least for this problem. Sorry. Yeah, I know.
You haven't even explained it.
I know, I'm sorry. It's tragic.
Are you gonna crush my dreams every single time, Chris?
I know. What's that?
Are you gonna crush my dreams every single time?
You know what, John? I'm sorry. That's just what math teachers do. We just like to build you up just a little bit so you think you're doing something right, and we just like to make you feel small again.
Maybe I'm a mess, yes.
Did you say there was going to be 5 of these on the test?
You know what? For everyone else, it's going to be 2, but for you, it's only going to be 5, just because I'm a nice guy. No, just 2. Okay? Yeah, these are the hardest ones, but they will be worth 15 points in each.
They are not hard, it's long.
They are, you're right. You know what, and I might have said this before, I equate it to mowing my lawn. They're not difficult, but I gotta do it sort of thing, and it might just take forever. Okay. All right, everybody good with this, guys? We'll finish this off. We'll say, therefore, by basis and inductive steps, John's dreams are crushed. Oh no, the result holds.
It's
Started writing that.
it's okay. They're basically made of glass.
Do you need a hug, brother? Seriously. I'm starting to feel bad for you.
Can we also say the formula is true?
Sure, absolutely. If you want to say, because that's really what it is. It's a formula for the sum of the first k or nth terms. Okay? Yeah, whichever way you want to do it. Okay, John?
Can you explain the inductive hypothesis?
Absolutely. John, didn't we say before that we assume that 1 plus 2 plus 3 plus k squared is equal to this? That's what we assume to be true. Okay?
Where did the k come
Well, remember, we assumed it true for all n equals k's. So we have to use a different variable because we're assuming. Okay? So we just basically plugged in k, that's all we did. And then down here, when we let n equal k plus 1, that's where we utilize the inductive step. Okay? So does that make a little more sense?
from? No, because can you
Right, the beginning part?
yeah.
Okay, so because this is valid, so basically if the basis is valid, then you just say, okay, well, I know it's true for small n, then I just want to assume it true for a different variable. Let's call that k. Okay. So we just make a different variable because we have to assume it to be valid.
okay, so you're just swapping here.
Yeah, we're just swapping variables because we're assuming it true for a different one. Okay, does that help, John?
Yeah.
Okay. Other questions, guys? Okay. So, this time we'll deal with some exponential expressions. Okay, so the other ones, we started with linear, now we went to a quadratic one. Let's go ahead and do exponentials. So, I want to prove that the first n base 4 sums is equal to 4n plus 1 minus 3 over 3. Okay, so, let's go ahead and prove, or disprove. It'd be really nice if we could disprove it, right? Because then we'd be done.
Well, one of the 2 questions on the exam disproved, so we can finish after like the second time.
You know what? You could try to disprove it, but they'll all work. Sorry. And I'll make sure that I work through the exam before I give it to you guys to make sure that they all work. So, by the way, if you guys get a problem for homework that doesn't work, you're wrong. Okay? I always make sure that they all work, okay, beforehand. So sorry about that. And same thing on the examination. So if you just say I disprove this, go back and do it again unless you want to start with like a B instead of an A. Alright. So, we want to do our basis step. Okay, so we're approved. Let's just go ahead and let's let n equal 1 this time. Okay, because the other times we've been letting n equal 2 and 3. So, let's let n equal 1. Okay. What would that look like, guys, if I let n equal 1? 1 equals 4 to the 1 plus 1, okay, minus 1 divided by 3, right, guys? So, well, this one doesn't work out.
Yeah, it's 4, it's 4. The first one's 4,
Oh.
not 1.
Wait, where?
The one on the
Four
right,
to
on
the
the
power
left,
of
on the
one
left
is
is
four.
bigger than 4.
Oh, no, it doesn't.
No, wait,
No,
the
it's
first one is 1.
Yeah, the first one's 1. So, you know what?
So it doesn't.
But
No,
the
it
problem
does.
is yeah, and that's the
There we go. Sorry. After I just got done saying none of them work. Of course. Alright. I just put the wrong domain value in there. I'm sorry, that's a copy error. Okay. Now you can't do that on the test. Okay, you can't just scratch out the number and substitute what they want. So,
So now we have to do 1 plus.
Still doesn't work.
no, it does. Okay. So, this is going to be 0. So this is the 0th term. Okay, so really what happens is we start like a new index. Okay, so this would be the 1 would be the 0th, 4 would be the first, 4 squared would be the second. Okay, so yeah, so we're going to let n equal 0. Okay, sorry about that. So this guy right here is the 0th term. Okay, so whatever the initial value is in the index or in the domain, that's where you guys start at. So if I just said for n equals -5, 1 would be -5, 4 would be -4, 4 squared would be -3, just like an array. Okay, same sort of thing. All right? This time it does work, because 1 is going to be equal to 3 divided by 3. Okay?
So in a case like this, if we set n equal to 1, it would have to be 1 plus 4.
Right, that's correct, because it would be the 0th and the first term. Okay, and that'll give you 5, and then over here that'll give you 15/3, which would still be valid. Okay, yeah, that's correct. Okay, does that make sense to everybody, guys? If the domain starts at 0, this is the 0th term. Okay, so obviously the basis step holds. Okay, so our second step, the inductive hypothesis. Thus, the basis holds for small values of n. Let's assume the result holds. So we assume the result holds for all n equals k, where k is an integer. Okay. Thus, instead of using n's, we're going to use k's in now our formula. So thus, 1 plus 4 plus 4 squared plus 4 to the 3rd plus 4 to the 4th plus plus 4 to the k now is going to be hopefully equal to 4 to the k plus 1 minus 1 divided by Okay, so let me give you guys a chance to copy that down. While you guys are doing that, I'll erase it over here, but, any questions about either our basis or our inductive steps? Okay, hopefully they're not too difficult for you guys. I'm assuming that the third step is gonna be the tough part for everybody. Okay, so no questions, guys? Okay, so now let's do our substitution step. Let's let n equal k plus 1. So third step. Let's let n equal k plus 1. Okay, by substitution. We are going to say that the original formula, 1 plus 4 plus 4 squared plus 4 cubed plus 4 to the 4th plus plus 4 to the n, which is equal to 4 to the n plus 1 minus 1 over 3. Okay. Now is going to become the exact same thing, except now we substitute k plus 1 back in. Okay. So, does somebody think they might know what this is going to look like after we substitute k plus 1 back in for this?
Mhm.
Okay. So, are we
Same
at this
thing,
time?
yeah, yeah, with the 1 plus 4
Mhm.
plus 4 squared
Uh-huh.
plus 4 cubed plus 4 to the power 4
Uh-huh.
plus all the way to the 4 to the power k
Uh-huh.
plus 4 to the power k plus 1.
Perfect, thank you, sir. Okay. So guys, do you see what he did there? He just took and copied the exact same thing down. He just plugged in a k, and then he just went one more term. That's the k plus 1th term. On the right-hand side, 4k plus 1 minus 1 over 3. So 4k plus 1 minus 1 divided 3. Okay. So, let me make sure that's okay with everybody. Okay, I'll give you guys a second to copy that down and then a chance to ask me some questions. Okay, just a lot of copying, right, guys? Okay, same stuff over and over and over again. That's why sometimes students think these are tough, but it's really just copying stuff.